In this video, I'm going to solve the ALEKS problem called Solving a Right Triangle. This problem is going to give us a triangle. We're going to know one side length and two of the angles. That's a 90-degree angle. That square there tells us it's a 90-degree angle. We have to figure out the value of the other two side lengths and the other angle. So the first thing that I want to do is figure out this angle capital B. I think that's the easiest place to start. One of the relationships that we know for triangles is that the sum of all of the angles is going to add up to 180 degrees. So we can use that to figure out the angle B because we know two of the three angles. We know we have a 90-degree angle. We also have a 42-degree angle, and then we have that unknown angle B. I'm just going to use a calculator for this. 180 minus 90 minus 42, that angle is 48 degrees. So that is angle B. Now that we know all of the angles in this triangle, we're going to be able to use our trigonometric relationships, sine, cosine, and tangent, to help us figure out the different side lengths. Let's start just by writing down our mnemonic device, SOHCAHTOA, which helps us remember the relationship between sine, cosine, tangent, and the sides, the opposite, the hypotenuse, and the adjacent sides for any given angle. So let's go ahead and start with angle 42 degrees. We can use this angle to help us figure out both the side length A as well as B, just not at the same time. If we're going to be focusing on this angle right here, I'm going to go ahead and highlight it. For this particular angle, the opposite side of that angle is side A. That is the opposite. The other two sides, one of them is the adjacent and one of them is the hypotenuse. The longer side is the hypotenuse. The shorter side is the one that we call the adjacent side. So if we're trying to figure out, let's just say we're going to start with side A. If we're trying to figure out side A, we are looking for a relationship between our unknown side A and the known side length, which is the hypotenuse. So we want a relationship between O and H, and that is this relationship right here. The sine of that angle, 42 degrees, is going to be equal to that unknown side. I'm going to go back to calling it A. That's what it's designated in ALEKS, over the hypotenuse, which has a length of 26. Let's just kind of simplify this equation a little bit. Because we're trying to solve for A, let's go ahead and multiply both sides of this equation by 26 so that we can isolate that A variable. We're going to get 26 times the sine of 42 is equal to A. Make sure that your calculator is in degrees, not in radians, and then go ahead and carry out the math on this. 26 times the sine of 42 gives us a side length of 17. ALEKS wants the answers to the nearest tenth, so that's going to be 17.4. That's my side length of A. So now we're going to do a pretty similar thing to solve for the side length B. We've identified, in terms of the 42-degree angle, we've identified this as the adjacent side. So we are looking for a relationship now between the adjacent and the hypotenuse, and that is the cosine relationship. The cosine gives us the relationship between adjacent and hypotenuse. Again, for the 42-degree angle, the cosine of the 42-degree angle is going to be the adjacent, which is our lowercase b, over the hypotenuse, which is 26. Let's do the same thing. Let's get rid of the 26 in the denominator. And that gives us 26 times the cosine of 42 is equal to b. We'll use our calculator to solve. 26 times the cosine of 42 is, to one decimal place, is 19.3. I just wanted to add here real quick, you could absolutely have approached this problem by using the 48-degree angle to solve for B and also solve for A. You would have used a very similar strategy as what I did here. You would have come up with the same answers because it's not going to matter which of these two angles we use to solve the problem.